Okie dokie, guys. So we're going to start our new module, and our new module will be all about exponentials and logarithms, mainly logarithms. So we're going to talk about 6.3 today. In 6.3, you're really going to be exploring exponentials, but before they have you exploring exponentials, they want you to know the difference between linear, exponential, and quadratic. Actually, I added on the quadratic because it goes so nicely with this. So this is a little bit of extra stuff. Mainly, your assignment is going to be about linear and exponential. But I want you to know both of these because I think it's pretty easy to deal with both of these. So what they're going to be doing is they're going to be giving you tables. And I have like 3 tables here. So there's 1, there's 2, there's your third one. I'll go ahead and number these. 2, and there's the first one. So they want to know, are they linear, exponential, or quadratic in nature? And if they are one of those guys, they want you to tell us what their function is. So it's nothing too crazy. If it's linear, you're going to be writing y equals mx plus b. If it's exponential, you're going to write a different equation. I'll show you what that is. You won't have to worry about writing quadratic functions or anything like that. Nothing crazy. So let's go ahead and talk about how we do this. So when you look at a table, in order to know if it's linear, exponential, or quadratic, you're going to perform what I call differences or ratios. So let me show you what I mean by that. And difference just means subtraction. Ratio just means I want you doing some division. Okay? So what I mean by a difference. So if we're looking at graph number 1, you're going to take 6 and we're going to subtract 5 from it. So 6 minus 5. This is what we call a first difference. And so 6 minus 5 is 1. And if this is linear, what's going to happen is when you do all the first differences, you're going to have a common first difference. In other words, they're all going to be the same number if this is linear in nature. So let's check this. So we're going to do the next guy. So we're going to take 7 minus 6. 7 minus 6 is 1. So far, they're the same, right? Well, let's check one more. Let's take 8 minus 7. And that's 1. Since all of these first differences are coming out to 1, that's what we call a common first difference. And that means that this guy is definitely linear in nature. Okay, it is a linear function. That's what's going on there. We'll talk about how to write this equation here in a couple minutes. So let's take a look at graph 2. Let's figure out what this guy is. Well, if I look at this guy, if I take 4 minus 2, because we're going to check first differences. If I take 4 minus 2, I get 2. If I take 8 minus 4, I get 4. Well, right away, those don't match. So I'm going to stop right there. So maybe it's not linear. Well, we're going to do another idea. What if these are a ratio? Ratio is just, remember, it's just a fraction. So what if we divide our numbers? Instead of taking 4 minus 2, let's take 4 divided by 2. And that gives us 2. And if this thing is exponential, because exponentials will actually have what we call a common ratio. Linears have a common first difference. Exponentials have a common ratio. So if all these numbers end up being 2, then that means that what you have right here, this function, is exponential in nature. So 8 divided by 4, well, that's 2. So far, so good. It's all matching up. And we check 16 divided by 8, that gives us 2. So since all of these are the same, that means they have a common ratio. So that means, come back. That means this guy is exponential in nature. And we'll talk about how to write its equation here in a moment. My last guy, well, if you haven't guessed it, you've seen the linear, you've seen the exponential, this guy's actually going to be quadratic, and let's talk about how we can check that first. So if you check the other two guys, if you check, the exponential and you do ratios, 4 divided by 1 is 4. And then you come down here and you take 9 divided by 4, and you're going to get 2.25. Obviously, those don't match up. So that makes no sense. So it's not exponential. And if you check first differences, so getting rid of that, if we check first differences, well, I get 3 here, and in here I get 5. Notice those don't match up. But if you continue and do what we call a second difference, quadratics, if you have a function that is a quadratic, if you take the second difference, what's going to happen is you will see that they have a common second difference. So 5 minus 3 equals 2. So let's get the last guy down here, and let's check and see if it comes out to be 2. This is what we call the second difference. If all the second differences match, then that means what you're looking at is a quadratic. So if I take 16 minus 9, that gives me 7. And if I look at the second difference here, 7 minus 5, I get 2. See how the 2 keeps matching up? And if I gave you the rest of this chart, the 2's would keep matching up. So that's what we call a common second difference. Common second difference. And because of that, that means what you have is a quadratic. Now again, in your assignment, you're not going to talk about quadratics or anything like that, but I wanted to discuss them here because it just fits so nicely with what's going on in. So now, given charts, given tables, you could use first differences, ratios, second differences to tell me whether this thing is linear, exponential, or quadratic. Now, the other thing that they're going to want you to do is they're going to want you to be able to give us the equations to these. Okay? So let's talk about how we find the equation. Well, if you are linear, you're writing y equals mx plus b. Cool thing is, all you got to do is fill in the m and fill in the b. The m comes from the first difference. Super easy. So we know in this case our m is 1. Y equals 1x. Your b is whatever happens when x equals 0. So most of your charts will actually have 0 on it, so you'll know your b right away. You just look at what happens when x is 0. But since our chart doesn't have it on there, we need to go back and figure out what is 0. Well, we're going backwards by 1. So what is 5 minus 1? 4. So if it's not on there, use your slope to help you go backwards. Remember, it's like reversing the direction. Okay? So remember, it's like reversing the direction. So now we know what our b is. It's 4. So our linear equation would be y equals 1x plus 4. Again, in your assignment, they're going to have this guy on your table for you. So they're going to make it nice and easy for you. So don't stress about having to really work backwards, but know that you could work backwards to get to that 0. So down here for number 2, because again, they're going to want you to write the equation for this. We're not going to worry about the equation of the quadratic, so don't freak out there. So they want you to write the equation for this guy. All of these equations look like y equals a times b raised to the power of x. So all you have to do is figure out what a and b are. Well, the cool thing is, you already know what b is. B is that common ratio. So we know that our equation looks like this. 2 to the x. You just got to figure out what a is. And a is not hard to figure out. A happens when x equals 0. A happens when x equals 0. So again, your guys' charts will actually have a 0 on it, so it'll tell you what A is. But here, we don't have our 0, so we'll work backwards real quick. So in order to go forwards, we're basically multiplying by 2. To go backwards, you'll divide by 2. Just like what was happening up here. When we were going forward, we were adding by 1. To go backwards, you'll subtract by 1. Okay? So it's just like the opposite of what's going on. So 2 divided by 2 is 1. Now you know what your A is. Your A has to be 1. Again, in your assignment, they'll pretty much tell you what 0 is. So it's not like you're doing anything crazy. You just really got to check the differences and things like that. So super easy to write these equations from your guys' table. Nothing crazy going on there. Okay? And then after this, after you kind of did a little experimentation figuring out what's linear, what's exponential, and I showed you what was quadratic just because it fits so nicely in here, now we're truly going to dive into exponentials. And so what we call the exponential equation deals with a new symbol for us, a new kind of like a symbol, a number in disguise, which we call E. E is an irrational number like pi, like remember pi 3.14 blah 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 15 whatever. So E is like that. And how we find E is you take a limit of this expression right here, 1 plus 1 over n to the n. Okay, limits and all that stuff, you're not going to have to worry about taking limits or anything like that. I'm just telling you what the number E comes from. And the reason why we have E, and right here I give you the approximate for it. E is 2.718281827 blah blah blah. It just keeps going and going and going. Again, remember it's like pi. But the reason why we use E is because it matches a lot of things that happen in real life with us. For example, we use E in like compound interest, stuff that is continuously compounding. E is used in exponential growth and exponential decay, which we will talk about much later on. Actually, we talk about it in 6.8 when we get there. So you'll get to see E again in a much later date, but this is what we call the exponential equation, y equals e to the x. This is the one that when we think about exponential equations, this is what we think about. Okay, so there really are other exponential kind of equations out there. They don't always have to have e, like what you saw a moment ago. We had y equals 1 times 2 to the x. Okay, but when we think about the real life and the real world, when it comes to exponential equations, we're dealing with e. E is usually our exponential guy that we default to. Okay? So I just wanted to give you a heads up on that. So when you see the letter E, just think it's irrational. It's like pi. Okay? If you want to dive more into the letter E and learn more about it, go to the book on page 431. You can see a lot more information about where E is coming from. Okay? It's pretty cool. It's pretty cool. And just so you know, exponential graphs, they look two ways. Exponential graphs, when we look at them, this is a rough graph of what E looks like. So that's y equals e to the x. This is what we call an exponential growth graph because over time we're shooting up and we're growing, we're growing, we're growing. The other type of graph that you will have, okay, is the exponential decay. That's a decay graph. Okay? And again, like I said, we're going to talk more about those all the way in 6.8. And the cool thing in this one is you guys aren't doing any graphs. Okay? So this module, this unit right here, the last few sections in chapter 6, there's no graphing. A lot of this is, all of this is going to be straight algebra. So just wanted to give you a kind of a brief update on what E means, where it's coming from, what it's used for. It really represents a lot of our real life situations. E is what pops out in nature. So let's dive into a little bit more of what you're going to be doing. So in 6.3, 3, they really want you to solve exponential equations. And solving exponential equations is not hard. It's pretty straightforward. It's rather easy, I promise you. So when solving exponential equations, the first thing that you're going to want to do, or that you're going to know about, is this right here. That what this is saying is that if your bases are the same, then that means the exponents have to be the same. And that's going to be our key to solving exponential equations. We're going to make their bases look the same, so that way all we have to do is set the exponents equal to each other, which makes it easy to solve. Okay? So if we can get our exponential equations to have the same base, then it's all over but the crying. Okay, so I've got 3 examples coming up right after this where we're going to get the bases to be the same. So here's our first guy. So notice right now my base is 2 and 16. Generally, when you're looking at this, you want to take the larger number and you want to try and convert it to the smallest base. So this is my largest number right here. So I want to try and get this guy to be 2 to some power. And 16 does convert down to a 2 to a power. So if you think about this, if you try 2 times 2, so that would be 2 squared. Well, that gives us 4, so that's not 16. What about 2 cubed? Well, that's 2 times 2 times 2, which is 8. So we're almost there. 2 to the 4th. 2 times 2 times 2 times 2. There it is. 16. So 16 over here really is 2 to the 4th. See, we converted it to a base that makes both sides match, right? So both bases match. And what we just talked about a moment ago, the moment both bases match, you can set their powers equal to each other to solve. So that's what we're going to do. Since both of these bases match, that means their powers have to match. And now, that's something we could easily solve. Divide by -1, divide by -1, x is equal to -4. And that's your answer. That's how easy this is going to be. All you have to do is get your bases to equal each other, and then you set the exponents equal and kick out an answer. So, I feel like I jumped over a problem. Yeah, I did. So again, my 2 bases are 2 and 4. Make 4 look like the smaller base. And you just saw this a moment ago. 2 squared will do that because 2 times 2 is 4. So we have 2x to the x minus 1 equal to 2 squared. See, my bases are the same. And since your bases are the same, that means the exponents equal each other. And now that's something you could easily solve. All you got to do is add 1 to both sides. 2x is equal to 3. Divide by 2, divide by 2. So x equals 3/2. And there you go. It really is that simple. There's no catches. I got one more example. If you can do this, you can do anything on 6.3. So this guy right here, oh look, E. Cool thing is, my E's are already the same base, right? So if I wanted to solve this, all I have to do is set my exponents equal to each other because they're already the same base. So 3x equals 2 minus x. And now you're ready to go. Get all your x's on one side, and then do some division. So we're going to add x. That gives us 4x equal to 2. Divide by 4, divide by 4. X equals 1/2. And that's really what 6.3 is about. It introduces the idea of E, a little bit of information about exponentials. You learn how to find out if a table is linear or exponential and write its equation. And then you do some solving a little bit later on. Okay, so there you go. That's 6.3.